This is the third part of the chapter real numbers. In this video we will learn about irrational numbers. What are rational numbers and irrational numbers? We will revise what are these. See, in the word rational there is this word ratio. Ratio means it is in the form of p by q. Okay, it is in the form of p by q. It has numerator and denominator. Okay, so rational number, it is a number that can be expressed in the form of p by q, that can be denoted or expressed in the form of p by q, where q is not equal to 0, where q is not equal to 0. See, in any number, if the denominator is 0, then it is undefined, right? So here rational number, it is a number that can be denoted in the form of p by q, where q is not equal to 0. For example, take 2 or 3 or 1 by 2 or 1 by 4 or any number 6 by 7. See, 2 can be written as 2 by 1, 3 can be written as 3 by 1. So these all are in the form of p by q. Okay, and what are irrational numbers? Irrational numbers are the numbers that cannot be expressed in the form of p by q, cannot be expressed in the form of p by q. Okay, examples are root 2, root 3, root of any prime number, root 5, root 7, okay, and 2 plus root 3, okay, and pi, the value of pi is 22 by 7, pi is 22 by 7, okay. These all numbers are irrational numbers. We know that these are irrational numbers and we have to prove them. In this video we will see how to prove them. Okay, this topic is very important. This proving as irrational is very important from examination point of view. In every shift, in every year, this question is being asked. Okay, you should learn it properly. Okay, let us start. See, theorem 1.2. Let p be a prime number if p divides a square, then p divides a, where a is a positive integer. Here, what are the conditions given? P is a prime number and p divides a square. These two conditions are given, and it is given p divides a. We have to prove this. Okay, so proof. Let the number a. See here, p divides a square means, for example, take any number a square divided by p. Okay, p divides a square. So take any number like 16, a as 4. If you take a as 4, then a square is 16. So 16 is divided by the prime number 2. So p is 2. Okay, so we have to prove that a is 4. A will be divided by p. Okay, we have to prove this one. Okay, so a is a number. You can take the prime factorization of a as p1, p2, p3 up to pn. That means p1, p2, p3, these all are the factors of a. Okay, these all are the factors of a, and these all are prime numbers. Okay, so squaring on both sides. Squaring on both sides, you get a square is equal to p1, p2, p3 up to pn into again p1, p2, p3 up to pn. When you square this, you get p1 square into p2 square into p3 square up to pn square. Okay, this is a square. Here p1 square, p2 square, p3 square These all are factors. These all are factors of a square. So here P1, P1, P2, P3. These are prime factors. These are prime factors of a square. See, for example, if I take a number 36. If I take a number 36, 36 is 4 into 9. See, 4 into 9 is 4 is 2 square, 9 is 3 square. So these two are factors. Like 2 square and 3 square are factors. But here 2 and 3 are prime factors. That means these are prime numbers. Okay, 2 and 3 are prime factors. The same way here, the same way P1, P2, P3. P1, P2, P3 are prime factors of a square. So here in the question it is given that P divides a square. So that means P is one of the prime factors. P is one of the prime factors of a square. So here in this see, these are the factors, and except these there are no other factors. So P is one among, see, P is one among P1, P2, P3. So P is one among these prime factors. And here we assumed that A is equal to, here we assumed this one. Okay, A is equal to P1, P2, P3 up to Pn. So here P is one among these. Okay, P is one among this. So here P divides A. Okay, hence proved. See, we use this theorem to prove any number irrational. Okay, next one, theorem 1.3. We have to prove root 3 is irrational. Okay, this is very important. You should remember this. Okay, see, this kind of theorems we prove by the method of proof of contradiction. That means first we will assume this as rational. First we will assume this number as rational. We will contradict. Okay, so let us assume root 2 as rational. Root 2 as rational number. So root 2 equal to A by B. Okay, so root 2 is equal to A by B. So A and B are integers. A and B are integers, and if A and B have a common factor, if these two numbers have a common factor except one. Okay, so if we have that common factor, we will divide by that common factor. So divide A by B with the, divide numerator and denominator with the common factor. So okay, divide A and B with the common factor. So here A by B is equal to P by Q. Okay, now P and Q have no other common factors. P and Q have no other, means P and Q are co-primes. That means P and Q are prime numbers. Okay. See, let us make this as first point. So root 2 is equal to P by Q. Okay, multiply P is equal to Q root 2. Okay, you multiply this here. P is equal to Q root 2. So when you square on both sides, squaring on both sides, you get P square is equal to Q square into 2. So P square is equal to 2Q square. Okay. See, with this one, this tells that 2 divides P square. This tells that this implies 2 divides P square. Okay. See, by the theorem 1.2, if P divides A square, then P divides A also. We have seen just now the theorem. So this implies 2 divides P. 2 divides P. So let us take this P by 2. Okay, P by 2 is some x. Okay, P by 2 is some x. So now squaring again, squaring on both sides. P square by 4 is equal to x square. This implies when you multiply, you get 4x square equal to P square. 4x square equal to P square. See, when you substitute this, P square equal to 2Q square in this, when you substitute in this, we get 4x square equal to 2Q square. This implies 4 by 2 x square equal to Q square. Okay, 2. So Q square is equal to 2x square. Okay, Q square equal to 2x square, and here P square equal to 2Q square. And this one tells, with the theorem 1.2, if P divides A square, then P divides A also. So here this one tells that if 2 divides Q square, then 2 divides Q also. Okay, then 2 divides Q also. Okay, this equation tells that 2 divides Q square. Okay, so 2 divides Q also. So here, sorry, 2 divides P and 2 divides Q. Okay, see, we have got this 2, and here as we have 2 as common factor of P and Q. Then P and Q are not primes, or not prime numbers. But here we have seen that P and Q are co-primes. Here we have seen that P and Q are co-primes. But from first equation, we have P and Q are co-primes. This is a contradiction. And this contradiction has arisen because we have assumed root 2 as rational number. Okay. Therefore, this contradiction has arisen because of our wrong assumption that root 2 is a rational number. Therefore, root 2 is irrational. Root 2 is irrational number. Okay. Next one. Fifth example. Prove that root 3 is irrational. Okay. The same process we will do. First, assume proof. Assume root 3 as rational number. So, root 3 is equal to P by Q. Here P and Q are integers. So, if P and Q have a common factor except one, then let's divide P and Q with that common factor. So, if you divide P and Q with the common factor, you get some prime numbers. X and Y. Okay. So, here X and Y are co-primes. Okay. That means they don't have any common factor. So, this implies root 3 is equal to X by Y. When you multiply X equal to root 3Y. Okay. Squaring. When you do squaring on both sides, you get X square equal to 3Y square. Okay. See, from this equation we can tell that 3 divides X square. 3 is a factor of X square. So, here 3 divides X square. According to theorem 1.2, if P divides A square, then P divides A also. So, this implies, see, if 3 divides X square, then 3 divides X also. 3 divides X. Okay. So, this means 3 divides X. So, let us take this as A. So, here when you multiply, X is equal to 3A. When you square on both sides, X square equal to 9. 3 square is 9, A square. So, if you substitute this one, if you substitute this one here, see x square is 3y square. 3y square equal to 9a square. So y square equal to 9a square by 3. Okay. See, from this equation y square equal to 3a square. From this equation 3 divides, we can say that 3 divides y square. So if 3 divides y square, then 3 divides y also. According to theorem 1.2. According to this theorem, we can say that 3 divides y. Okay. Here we have seen that 3 divides y and 3 divides x. Okay. But here we have assumed that x and y are co-primes. Here from these two equations, here from first and second equations, we got 3 divides x and 3 divides y. This means x and y have factors. X and y have common factors, that is 3. X and y have common factor, that is 3. That is 3. Okay. But we assumed here x and y are co-primes, but we assumed x and y are co-primes. So this is a contradiction. This contradicts this statement. This contradicts this statement that x and y are co-primes. So this contradiction has arisen due to the wrong assumption. This contradiction has arisen due to the wrong assumption. So our assumption is wrong. So root 3 is irrational. So our assumption that root 3 is rational is wrong. Okay, root 3 is irrational. In 9th class you might have studied if you add or subtract or multiply between the rational number and irrational numbers, what do you get? Okay, we will revise this quickly. See, rational number is r and irrational number is I. Okay, so if you add rational number plus rational number, you get rational number as answer. Okay, if you subtract rational number minus rational number, you get rational number as answer. And if you multiply rational number and rational number, you get rational number as answer. Okay, and here on the other side, if you take rational number plus irrational number, you get irrational number as the answer. If you subtract rational number and irrational number, or if irrational number minus rational number, you get answer as irrational number. Okay, if you multiply rational number and irrational number, you get answer irrational number. Okay, and if you divide rational number by rational number, you get rational number. If you divide irrational by rational, you get irrational, or if you divide rational by irrational, you get irrational. Okay, if in any operation, if there is irrational, the answer will be irrational. Okay, answer will be irrational. show that 5 minus root 3 is irrational. Okay, we have to follow the same process. Here, let us assume, let 5 minus root 3 is rational number. Okay, so 5 minus root 3, rational means we have to denote it in the form of p by q. Okay, and let p and q have common factors except 1, and divide p and q with the common factor. So after dividing we get a by b. Okay, let us assume this as a by b, a and b, where a and b are co-primes. They don't have any common factor. Okay, so here 5 minus root 3 is equal to a by b. Okay, 5 minus root 3 is equal to a by b, and here a and b are integers, and a and b are integers. Okay, you take a by b to the left side. 5 minus a by b is equal to root 3 to the right side. 5 and a by b both are rational numbers, and here if you subtract rational number to rational number, you will get a rational number. Here 5 is a rational number. 5 is a rational number, and a by b is a rational number. So if you subtract, so rational number minus rational number is equal to rational number. Okay, so 5 minus a by b is equal to rational number. But 5 minus a by b is root 3. But 5 minus a by b is equal to root 3. So here, so root 3 is a rational number. But here in the previous example we have proved that root 3 is irrational number. But root 3 is an irrational number. So this contradicts our assumption. This contradicts this statement. This contradiction has arisen because of our wrong assumption. Therefore, our assumption that 5 minus root 3 is rational is wrong. Therefore, 5 minus root 3 is irrational. Okay, next one. Show that 3 root 2 is irrational. Proof. Let us assume that 3 root 3, 3 root 2 is rational. Let us assume that 3 root 2 is rational. So, rational means it is expressed in the form of P by Q. 3 root 2 is equal to P by Q, where P and Q are integers. P and Q are integers. So, here take 3 to the other side, P by 3Q. So, here as P, 3 and Q are integers, then P by 3Q is a rational number. So, we get, when you divide P by 3Q, then you get answer as rational number. So, but from this equation, P by 3Q is equal to root 2. So, from this equation and this equation, we can say that root 2 is rational number. But we know the fact that root 2 is irrational number. So, this contradicts the statements. This contradicts the statement that root 2 is irrational number. So, this contradiction has arisen due to our wrong assumption. Therefore, our assumption is wrong. Our assumption is wrong. Therefore, 3 root 2 is irrational number. 3 root 2 is irrational number. Okay. We will do the exercise questions in the next video. Thank you.